I'll be diving into is this cellular landscape that we see in the background of this image. And the second project that I'm going to be going through is how I modeled the DNA in this cell nucleus using dynamics and splines and sweeps. So I'll start here. And before I dive in, let me give you a little bit of science background on this piece. This was a journal cover design for a scientist. Her research lab had just characterized how these three molecules that we see in the foreground interact. And these molecules are really important because they help guide cells in the developing brain. And that's what we actually see in the background is immature neurons, which are these blue cells, which are climbing up the rope-like processes of these green cells, which are radioglial cells. And what the neurons need to do is attach onto these processes and climb up them to get to the right place at the right time in the developing brain. And part of the way that they do this is if you looked really close at where this neuron was holding onto this radioglial cell, you could see these molecules coming together on their surface. And these molecules help send the signal to make sure that the cell behaves the right way, gets to the right place at the right time, and make sure that the brain develops correctly. So I'll be diving into how I made this cellular landscape. So here's what that file looks like in Cinema. As you can see, the foreground is mostly just a bunch of cloners. All of this molecular geometry is something that I pulled in with a different plugin called EPMV. We're not going to be looking at that today, so let's just turn that off and check out this background. So you can see here that I've got this field of cells, and they've got a couple important characteristics. They've got feet down here, little cell bodies here, and then these rope-like processes going up. And in addition to that, we have these neurons, which are a different kind of cell, and they are climbing up those ropes. So I'm going to be breaking down today how I created this. So let's get started. So the first thing I'm going to do is create a new matrix object. So what this will allow me to do is target everything to this object because I'm going to be using a combination of a bunch of different cloners. So I'm going to rename this base matrix. And I'm going to reset it from, instead of a grid array, I'm going to make it a honeycomb array. And I'm going to change it to be flat, like so. And now I'm going to start using it as a base to start building my cells. So remember, the first thing I need to do is create feet. So I'm going to take a cylinder, and I'm going to crank down the rotation segments to 6, and shorten it, and widen it a bit. And now I'm going to put a deformer on it. Put a taper deformer on, fit it to the parent, turn up the strength. Okay, so now we have sort of a really low poly little cell foot. I'm going to take this, I'm going to rename it RGC foot because they're radial glial cells, so I'm going to be naming everything RGC. And I'm going to put that in a cloner. I'm going to rename this RGC feet. Put the foot there, and I'm actually going to target this cloner. I'm going to change it to the object mode, and I'm going to target it to the base matrix. Okay, so now I have all these radial glial cell feet targeted to that matrix. I'm going to turn off the taper so I don't have to look at it all this time. And right now it's a little too spaced out, so I'm going to go to the base matrix. I'm just going to tweak it until they come a little closer together. And you can either make your cylinder wider or bring these closer together. It doesn't have to be perfect, so I'm not doing any calculations here, just kind of eyeballing it until I get a little bit of get them pretty close together. All right, so now I am working with those feet, which is great. I'm going to make this cylinder a little bit taller. Go to taper, I'm gonna put it to parent again. And I'm gonna crank up the sub-height segments on my cylinder so I get a slightly cleaner result. So now you can kind of see a little bit better what I'm doing. All right. So now that I have that in place, the next thing I want to make is the cell bodies. Or actually, I'll start with the cell processes. So I'm going to take a spline. So I'm going to make a new helix. Set its start radius to 0, its end radius to 0, height to 2000. And I'm going to copy this cloner RGC feet. So control drag. I'm going to rename it RGC processes. And I'm going to put this helix in here, or delete the foot. And I'm going to rename this helix RGC process. So I can always find these things and know how I built it later. And right now you can see there's kind of a problem. I want these guys to be sticking straight up and they're off to the side. So I'm just going to change the plane that the helix is pointed in to XZ. All right. So now what we have is the feet and the processes, and they're sticking straight out of the feet. So the next thing I'm going to do is create the cell body. After I build all this base geometry, what I'm going to be doing is putting it all into a volume object to put the final model together. So to make the cell body, I'm again going to copy RGC feet. I'm going to rename it RGC cell bodies. And I'm going to tick it. I'm going to put it here, remove the foot. And now you can see right now it's like right on top of the foot, and I want to offset it a little bit. Usually what I would do is I would go to my cloner, go to transform, and turn it up on the X dimension. But as you can see, that's not working right now. And that's because I have it targeted to a matrix. So let's undo that. We can just offset it by another simple way with RGC cell bodies selected. I'm going to go to MoGraph effector, and I'm going to use a plane effector. And you can see almost automatically the plane effector is doing exactly what I need it to. So I'm going to rename this plane effector offset RGC cell bodies. I'm going to put it right above that just so I know what it's affecting. And I'm going to go to its parameter, and you can see already it's affecting the position in the Y dimension. So I'm just going to crank that up, move that cell body up higher. It's starting to look pretty good. Now I want to tweak the shape of the cell bodies a little bit. So I'm actually going to throw a deformer under the sphere. I'm going to use a combination of squash and stretch to make it a little taller. So put squash and stretch under there, fit to parent, and tweak the factor to first make it a little taller. And then the other deformer I'm going to use is a bulge. So I'm going to put that after the squash and stretch, fit it to the parent. Might actually need it to be a little taller, and turn up the strength. So I start to get kind of a tapered cell body with that's a little bit fatter in the middle, which matched the microscopy that I was looking at. These guys are looking a little crunchy at the moment. I'm going to turn up the segments. And they're also looking a little bit large, so I'm just going to turn them down. And then reset my deformers. All right, so now I have these kind of nice tapered cell bodies. And they're nice and aligned. But the one thing is, I do need them to be sort of at random heights. So I'm just going to tweak this and make them a little wider. There we go. A little bigger. Okay. So I need them to be at random heights. So what I'm going to do is going to, again, select RGC cell bodies. And I'm going to go to MoGraph again. I'm going to go to effectors, and I'm going to select random. And right now it's moving them randomly in every dimension. So what I want to do is only do that in the Y. So I'm going to turn off, set the X to 0, the Y to 0. And I'm going to crank up, or set the Z to 0 and crank up the Y. Now you can see the cell bodies are at different heights, but they start to run into the feet. So I'm going to go back to my offset, turn that up a bit, go back to my random. It gives me a little more space to work with. So now I have these cell bodies set off at a good, a couple different random heights. They start to look a little bit more organic. I'm going to go back and tweak my deformers a little bit again. There we go. So that's looking pretty good. They're a little too fat. So I'm going to turn that down a bit. Okay. So now I have these cell bodies. They're nicely offset. They've got the feet. They're nicely aligned with these cell processes. The next thing I want to do is actually create a nucleus for each of these cell bodies. So let me actually first rename this random so I don't lose track of it later. So I'll name it random RGC cell body height. And now I want another sphere on the inside of each of these. So I'm going to just copy cell bodies. And I'm going to set this first one to X-ray so I can see what I'm doing through it. And I'm going to go to this one. I'm going to name it RGC nuclei. So that's the organelle that contains the DNA at the center of the cell. I'm going to just get rid of these deformers. So we're just looking at a regular old sphere. And you can see almost immediately I've got almost exactly what I need, which is just that sphere centered in the cell body. And I might just crank it down a little bit in size. Okay. So that's starting to look really great. But obviously this is still just a bunch of separate pieces of geometry. So the way I'm going to bring it all together is by using the volume builder tools. So I'm going to go here, open up a volume builder, and also a volume mesher. And put it down here, and I'm going to name it RGCs outside. And I'm going to take the cell bodies, the processes in the feet, and also their effectors and toss them in there. The effectors it doesn't really matter that they're in there. It just helps me remember that this effector is affecting this cloner. That's all that is. Okay, and you can see right away we get these cells are starting to come together. Now, as I tweak the volume builder settings, I want this to be quick and responsive. And right now I've got a lot of copies. So I'm just actually going to go to this base matrix and crank down my count. And when I do that, because every cloner that I've created so far is targeting this base matrix, everything updates and stays aligned. So even if I had the RGCs outside, you can see it still has the cell nuclei nice and aligned in the middle. The cell bodies stay aligned with the feet, and the cell processes are where they need to be. So right now this looks okay, but I want a little bit more taper and smoothness between the cell processes and the cell bodies, and also with the feet. So I'm going to go to the volume builder, and I'm going to create a smooth layer. And when I do that, immediately you can see the processes are too thin. They get evaporated right away. So there's one way that I can tweak this is by going to the processes and adjusting the radius and density. So right now the density is only 0.1. If I crank this up, it basically creates more voxels along the length of this spline. So let me turn off the volume mesher for a moment, and you can start to see. So I've gone with 0.1, or let's crank this way down, you can see that there are a bunch of spheres or little voxels that are basically determining how this spline gets solved in the volume mesher. And if I increase this density, it increases the number of voxels that we get on that spline. So when I increase that density, it'll make it a little more robust against this smooth. I'm actually going to take this and put it above that. Or no, I don't want to do that. It's still not quite holding up, so I can also turn down the strength on this smooth and turn up the processes density a little more so it doesn't just get crunched out. And then go to RGCs outside. I can also turn this voxel size down. So just a lot of little tweaking to help this model come together. I'm also, because I've got some geometry kind of showing through on these guys, I'm actually going to add another smooth layer, but I'm going to have it only apply to the feet and the cell bodies, and that kind of helps smooth those out. And then the second smooth just helps taper the cell processes and the cell bodies nicely together. So that's starting to look, fairly decent. A little more smooth together. And what I'm going to do from here now is it's all looking pretty stiff at this point. So I'm going to take everything that I've created so far except the base matrix, and I'm going to put it into null. So using the shortcut Alt-G, and I'm going to rename this cells background, because I'm going to be putting another cell type in here later. And to make it look more organic, I'm going to put a deformer on this null. So I'm going to go to my deformers, grab a displacer, and throw it under this null. And I'm going to go to the shading for the displacer, go to noise, and I get a result. So this isn't quite what I'm looking for. I just kind of want more of like an organic, wavy feel. And right now it's displacing it in the direction of the vertices with like a really small noise. So I'm going to go to my object. I'm going to change the direction to planar. And then I'm going to go to my shading. I'm going to change the space to world. And I'm going to crank up the scale from 100% to 1,000, let's say, and see how that looks. I'm starting to get close, and it's still a little bit more detailed than I need. I want to make it a bit larger. So crank this up another 50%. And I'm going to go to my displacer, and I'm going to increase the intensity. Okay, starting to look pretty good. Again, still looks a little small, so I'll just crank it up again. All right, so I'm starting to get this nice organic deformation on this volume object. Then the next thing that I want to do is, right now, remember I set this displacer to planar. I'm going to also displace it not just along the x-axis, but also the z. So I'm going to copy it. I'm going to rename this one displacer z, and go to this first one and name it displacer x, just so I can remember which one's doing which. Change the orientation to plus z. And right now they are both the same shader, the same seed of the noise. So it's creating kind of a weird effect. So I'm just going to go to displacer z and offset the seed by 1 so that they're doing slightly different things in the x and z dimensions. All right, so now it's looking more organic, more reasonable. So the next thing I want to do is, now that I have these radial glial cells looking good, I want to add those neurons climbing up. So if we look at that final scene again, we can see these blue cells start low. We've got one here that's a little different. It's got a lot of different arms. And then they become more spindly. They just have 2 arms, and they start climbing up this rope. So I'm going to do this by creating another set of cloners. So I'm actually going to take RGC nuclei here, because I'm going to, again, make it a sphere. And I do still want it to be targeted to the matrix. I'm going to rename this Neuron. But there are a couple things affecting this nuclei object that I do not want actually affecting my neuron. So I'm going to delete the offset. And with neurons selected, I'm going to create a new effector. So use this plane, rename it neuron offset. And I'm going to crank up this Y a lot higher. Now, right now, I kind of, cranked out the number of voxels and density over here on my cell body. So my computer is spending a bit of time calculating it. So all I'm going to do is turn off this mesher and builder for now. But you'll notice when I do that, because all of these cloners are still under the same node with the displacers, I can still see what that displacement looks like, even though I don't have the volume mesher turned on right now, which is great. So I have this kind of like low poly version of my scene that is really nimble and I can keep working with as I set up these neurons. So with the neuron, right now they're too small. And I also need them to be spindly. So again, I'm going to use those deformers that I used before. So I'm going to grab a squash and stretch to make it longer and more spindly, like so. And I'm going to look at this with lines on and make sure that I've got enough subdivisions going on. I might need to tweak that. My neurons are still too low, so I'm going to turn up the Y. Okay, so I've got them kind of long, but I need to get a little fat part in the middle for where their nucleus is. So again, I'm going to grab a bulge deformer, put it under the squash and stretch, and turn up the strength. Okay, so I'm starting to get an okay result, but you can see it's kind of crunchy in the middle here because I don't quite have enough subdivisions on the sphere. So I'm just going to turn up those subdivisions so I get a slightly smoother result. Okay. And I'll just, tweak those deformers until I get a result that I like. So kind of going back and forth between the squash and stretch and stretching out those cells to make them long and tall and with a little fat middle. Okay, we're looking fairly good. And the nice thing is you can see already that these cells are displacing along with the displacer that I placed on this whole hierarchy. So I can turn those off as well and just kind of see these cells like so. And I need some more subdivisions on this sphere, so turn that up. All right, so it's starting to look pretty good. And I'm, happy with that shape. Might go back and tweak it more later. But all right, so I've got my basic neuron in place. The next thing I want to do is have it be climbing from left to right. So I want to make sure that this cell scene is kind of set to the scale that I'm going to need it at for my final composition. So I want it to be a bit wider. So I'm going to go again to my base matrix, and I'm going to increase the count going wide and maybe up a little in the height to give me more cells to work with and a better representation of the scene. So the next thing I want to do is have these neurons be climbing. So the way I'm going to do that is using, again, a plane deformer. So I'm going to select neuron. I'm going to go to MoGraph Effector, grab a plane, and I'm going to rename it neuron climbing. And make sure I can spell all right. There we go, neuron climbing. And again, this is going to be a positional offset, but this time I'm going to use a fall off. So I'm going to go to the neuron climbing plane effectors fall off tab, and I'm going to add a linear field. And almost immediately you can see I'm just about getting the result that I need. So if I drag this linear field, you get this goofy little animation. But I want a more gradual climbing. So I'm just going to grab that field and extend it lengthwise. And now you can see that the effects of this neuron climbing fall off along this linear field. And I'm going to turn that up a bit. And I'm also going to go back to my RGC processes, that helix, and make it bigger or turn it higher. So I've got a little more room to work with. All right, so now I have these cells climbing upward. And if I turn that displacer on again, I can kind of see that they stay nice and aligned with the cell processes here, which is great. Here, which is great. But one thing I realized as I was doing this scene is if I had neurons on every cell, it was a little confusing to look at. So I wanted to just have the neurons climbing up the processes, the front row of cells. And the way I'm going to do that is I'm going to hide them with a MoGraph selection tag. So with this neuron cloner selected, I'm going to go again to my MoGraph effector. I'm going to again use the ever handy plane effector. I'm going to name it neuron hider. And I'm going to turn off the position. I'm going to go to my fall off, and I don't have a MoGraph selection tag yet to work with. I need to make one. So I'm going to go to my base matrix, and I'm going to go to MoGraph and pick my MoGraph selection tool. Now, let me hide these cells real quick so we can take a look at this matrix. With the MoGraph selection tool, you can see now there are little dots in the middle of each of my matrices. And when I click over them, they highlight. So I'm just going to, holding down Shift, click on the matrices where I want there to be neurons. And you can see this creates this MoGraph selection tag on my base matrix. So now I'm going to go back to my cells. I'm going to make sure they're visible. Take a look at those neurons. I'm going to go to my neuron hider. And I'm going to first go to the parameter and make sure that visibility is checked so that this plane is going to affect whether or not these clones show up. Go back to the fall off, grab the MoGraph selection tag, throw it in there, and it immediately does what I need it to do, which is it hides all of the neurons that don't correspond to that front row of matrices that I selected. Now say I realize after the fact, I actually don't want this guy over here, but I do want some more, just like one row back. I can go back, select my base matrix. Again, use my MoGraph selection tool. I'm going to hold down Control and remove that matrix from the selection, and then hold down Shift to add some others. So now I've got the neurons over here, but not one over here. Because the last thing I'm going to be doing and adding to the scene is an immature neuron over here that hasn't started climbing. And instead of being spindly like this, it has a bunch of little arms. All right, so let's take a quick look at this, make sure we've got everything we need. We've got those RGCs in place using that volume builder. We've got the displacers in place to get a nice organic look. Okay. One other thing that I might do is, just so these neurons aren't perfectly overlapping with the cell processes, is use one of my plane effectors to offset them a bit, either a little bit forward, so that they're not perfectly overlapped. I also still need nuclei for these guys, so I'm going to go to my neuron. I'm going to copy it. Now that I have them nicely set up, I'm going to rename it neuron nuclei. And I'm going to go to this first neuron, make it X-ray so I can see what I do to these guys. I'm going to turn off the bulge deformer, and I'm going to turn the squash and stretch deformer down. So we start to get something a little shorter and smaller looking. And then also just shrink this. Okay. Okay, so now each of those neurons has a little elongated nucleus in it as it climbs upward. And we're just going to do a quick job of modeling that last little multipolar neuron that needs to be down there with lots and lots of little arms. So I'm going to grab a platonic object. And again, my volume builder is taking a bit of time to crunch, so I'm just going to turn it off for now. Go take my platonic, move it forward so I can see where it is. I'm going to hit keyboard shortcut C to make it editable. And I'm going to take my selection tool, turn on polygon selection, and start selecting some polygons around the face of this platonic. And then once I feel like I've got a sufficient, distribution of them selected, I'm going to go to my tools. And let's see if I can remember where it is. And I want a matrix extrude. Okay, so I can never remember where it is, so I'm just going to hit Shift-C, and that will bring up this little handy search bar. I'm going to type in matrix extrude. That gives me the matrix extrude tool. And I'm just going to click and drag and pull out those little arms. And you can see the settings over here. Right now it's doing a fair amount of rotation. I don't want it to do that much rotation. So let me turn that down to 2 degrees. And the length looks fairly good, but if I wanted to, I could lengthen or shorten it here. But that actually looks pretty close to what I want. Might turn it down a little bit. Okay, so obviously this is a really crunchy looking cell, but now that I have the basic shape, I can go back, make sure my selection's back to object. I'm going to take a subdivision surface, put that guy into the subdivision surface, and you can see it starts to look more reasonable already. Turn up the subdivisions. All right, so now that looks like a reasonable organic cell. I'm going to rename this multi-armed neuron. Now, right now, my subdivision surface center is way off for my object because I dragged it forward. So with that selected, I'm going to go to my mesh axis and go to my axis center. I'm going to select point center, include children, use all objects, execute, and that should center that. Or go just to my platonic, go to mesh axis, and center parent 2. So now if I select that subdivision surface, it is now centered to my platonic. And we can just scoot this guy into place in the scene. So have him be, over here, somewhere reasonable. And I can take him and put him into this hierarchy, and it will also be affected by that sort of organic deformer that I'm putting everywhere. And again, if we turn on that volume builder, volume mesher, that's how I got to that whole cellular landscape. So it's just stacking cloners on cloners and using volume tools. So if we look again back at that original scene, those are all the techniques that I used for the background that you see here. So now I'm going to switch gears and show you guys a different project. So let's just close this out. Yep. So the next project that I'll be showing you is for this illustration here, which is an illustration explaining how DNA is packed into the nuclei of cells. So you may have heard that in every cell, there are 2 meters. So that's about the same height as you are. There's 2 full meters of DNA packed into the cell nucleus. And it's the way that it's done is by wrapping that DNA around histones that forms chromatin, and then that chromatin is further organized within the nucleus into chromosomes, which are what you see in different colors here. And of course, it's a challenge to keep this all from getting tangled so that the cell can still use it and then also divide later. So that's what this infographic was about. And the challenge was to model the chromatin in the nucleus and make it look really packed. And in addition to that, have each chromosome kind of take up its own region in 3D space, because using microscopy, scientists have figured out that each chromosome kind of takes up its own little zone in the nucleus and like fills it up. So that was my modeling challenge here. So to close this out, we are going to open up this project file. And let me close this one first. So here's that project file. So there's a cell around that, so I can turn that cell off. And let's just take a look at this. So as you can see, I've basically got a bunch of sweeps here. I've got sort of the hero side of the nucleus where these splines are pretty neatly put together. And then in the background where I just kind of needed to, fill it in, I just duplicated some of those guys and put them back here, and it didn't really matter how much they overlapped or how tangled they looked. So I'll be showing you kind of how I created this noodly spline-filled object. So let's open up a new file. So the first thing that I am going to do is create a sphere, and I'm going to rename it container or containment. And I'm going to set that to be X-ray and increase the size a bit. And then the next thing I'm going to do is going to create another sphere. So I'll just control drag and take this one, and I'm going to name it hair target. And you can already kind of guess how I'm going to do this. So I'm going to take this hair target. I'm actually going to turn it into a hemisphere, and I'm going to shrink it down and put it into the middle here. So what I'm going to do is basically model the hair into half of this sphere, just to make this a little quicker to demonstrate versus doing like the whole sphere. And you can also see in that previous project, I just did part of it and then duplicated some of the splines elsewhere. Now, one way you might be thinking of doing this is you just take your hair target and you go to simulate and hair objects, you just add hair. But part of the challenge is each of these splines actually needs to be really, really long. So one way I tried to go about this for a while is I, set my hair really, really long, and then, had the containment start out here and like try to push it in dynamically. But that was just really difficult to do and took a lot of time. And there's a way easier way to do this. So actually, let's just delete this hair for now. And what I'm actually going to start with is I am going to create a helix. And I'm going to set its start radius to say 20 and its end radius to 30. And its end angle, put a 0 in here, 7,200. Okay, and what you can see is I'm starting to create a really long spline, and I'm going to crank down the height to, say, 70. And now I'm going to take this helix, I'm going to grab a cloner, throw the helix inside that cloner, and I'm going to target this cloner. I'm going to make it an object cloner. I'm going to target the hair target. And right now you can see they're all overlapping. And they're all kind of pointed the wrong direction. So I'm going to turn around using the transform tab of the cloner and then also float them out a bit. Okay, so now I've got all these helix splines starting to fill up space in the nucleus, but you can see some of them are overlapping, which I don't want. So with my cloner selected, I'm going to go to MoGraph, Effector, and use Push Apart. And right now it's set up to be too wide. So I'm going to set this down to, say, 30. And I'm actually going to use, well, let's see, if I use Push Apart, it might push them outside of the nucleus. But actually, this is looking pretty good. But for the purposes of this demonstration, I want this simulation to run a little faster, so I don't quite want so many. So I'm going to use Hide and turn this down a bit. Okay, cool. So now I've got a bunch of these helix splines, and I want to start running a dynamic simulation on them. So I want to convert these guys to hair. So I'm going to take this cloner, and I'm going to right-click and click Current State to Object. And now this creates a hierarchy here called cloner, and it has all of my helices inside it as just splines. Now, if I want to go back and tweak that base later, I want to have this cloner backed up. So I'm going to, with that selected, I'm going to click Alt-G, create a null, rename it backup or hider or both, and turn it off so I don't see it, and just put it at the bottom here. Same thing with that Push Apart if I want to go back and tweak that later. Okay, so now I have all these splines. So what I'm going to do is I'm going to select all of them, and I'm going to right-click and click Connect Objects and Delete. So now I have just one spline that has all of those clones of the helix as segments. Now with that selected, I'm going to go to Simulate, Hair Edit, and click Convert from Spline. And now what that's done, if I take this cloner, I'm going to just put it in my hider. I select this hair object. Now what I have is from those splines, or from that one spline, I've gotten this hair object. And if I hit play, it behaves as you would expect a hair object to. It's got roots and gravity affects it and all that. Great. So that's not exactly the dynamics I need. So I'm going to start tweaking that setup. The first thing that I'm going to do is go to Forces. Actually, I'm going to keep gravity on for a bit while I get this set up. I'm going to turn off this fixed roots, and I'm going to set the hold roots to 0. Now, when I do that and I hit play, you would kind of expect them to fall, but you can see, let me keep them selected, their roots are actually still attached. So I need to do one more step. So I'm going to go to my Simulate, Hair Edit, and I'm going to click Unroot Guides. And now if I hit play, they just fall like that. Now, remember this container sphere, of course, that I made earlier isn't really doing a great job of containing. So I'm going to click the container sphere. I'm going to go to my tags, and I'm going to go to my hair tags and make it a hair collider. Now, if I just hit play right now, they explode to the outside of this sphere. And what I need to actually do is make this sphere editable and reverse the normals so the inside of it collides instead. So with the container selected, I'm going to hit keyboard shortcut C to make it editable. And then I'm going to go to my mesh menu, go to normals, and just click reverse normals. So now the normals on this sphere are pointed toward the inside. And if I hit play, you can see those splines. Like, select the hair so you can see it more easily. The splines now collide with the inside of my sphere. And this is why I left gravity on, just so I can get this part of the dynamic set up. But now that I know I've got my collision set up, I'm going to go to my Forces under my hair object, set my gravity to 0. And now if I hit play, nothing happens. So now I'm going to start adding in other forces to start tweaking this. I'm going to extend my timeline to, say, 500 frames. So I've got plenty of runway to work with. And I'm going to go to Simulate Forces, and I'm going to throw in turbulence. Now if I hit play, and again, select that hair, I'm actually going to turn this container off. Trust me, it's there. it's containing these splines. You can start to see what's happening with this turbulence. I'm starting to wiggle these splines around so that they lose that, that nice regular look. It's kind of taking them some time though, so let's go and tweak their dynamics. So under the hair tag, under dynamics, the stiffness is currently set to 100%, and I'm gonna set that down to 2%. Now hit play. Starting to kind of get a better result there. I'm going to go to my turbulence. I'm going to turn my scale to 7%. And this was just stuff that I figured out from tweaking the simulation, starting to get kind of a result that I wanted. All right, so now we're starting to get that sort of complex, wiggly spline shape going on. Now, another thing is, in these areas where they're closer together, I want to make sure that they are not overlapping with each other, that they kind of collide with each other. But that's going to be actually a pretty heavy calculation to do. So let me go back, and there's one thing I want to check before I start turning on my hair-to-hair collisions. So under forces, I'm going to check hair-to-hair. But before I hit play, I'm going to go to my guides, and you can see the segments right now is set to 900. This was just kind of auto-populated when I created this hair object from those helix splines. I'm going to turn that down to, say, 150. Now, you see I start to get a kind of crunchy result here, but that is okay, because this is just going to kind of set the path of the spline, and I can add detail back in later. So now if I hit play, the simulation's running more slowly now because it's starting to calculate collisions between each of the hairs. So I can, play that out until I get a result that I like. Another way that you can do this is go to Dynamics Animation and click Relax. And this will keep the time here the same, but just run the simulation for however many frames at a time that you want. Okay. For the point of this demonstration, just to make it faster, I'm going to turn off my hair-to-hair, and I'll hit play and get a quicker result this way. All right, cool. So after letting the simulation run, let's say I'm happy with this result. It looks like my containment sphere, which we hid, is nice and jam-packed, full of these guys. Now, the next thing I need to do is make each of them a different color. So I need to convert them back to splines. So I first want to go to my generate and make sure that type is actually set to spline. As you can see, this actually starts tracing a spline to that guide that you can already see. And I'm going to right-click my hair, and I'm going to select current state to object. And now if I hide the hair, you can see now that I have another spline again, and it is all of those hairs in their current position as splines. Now I want to add a sweep to each one to make them all, so that I can make each of them a different color. So I'm going to just go with this hair selected. I'm going to go to spline and go to segments, and I'm going to click explode segments. And now this creates a spline out of each separate piece. And from there, I can apply a sweep object to each of them and make it different colors. So I'm actually going to undo this and make it all one again, just so you can see real quick what that sweep might look like and how you can add a little bit more detail. So I'm going to create a sweep object, put it on the hair. I'm going to add a circle, say. And there you go. So you start to get those nice noodles. Now, if I wanted this to, say, look even more organic, I can use my favorite deformer. So I'm going to go to my deformer, grab a displacer, put it under hair, and go to my shading and just put in noise. And I can start getting kind of that really detailed, wrinkly look that I had going in that prior piece. Okay. So another option, let me just put the sweep in here, is if you don't need each of your hairs to be a different color, you can go to generate in your hair object and just put circle. And that is actually, you can't really see because it's really thin. And the way we can make it thicker is take this hair material down here, put it on my hair object, and I'm going to go to this hair material, and I'm going to set the thickness up to 2 and 2. Okay, now what you can see is this has created a sweep on those guides. And remember the guides, we turned down the segments, so they're a little crunchy looking. But this has created a sweep on those guides directly from the hair object. So, a couple different ways to translate this, final geometry and, set of splines into what you need. So if we go back, that's how you can get a result like, what I used in this project to create all these different chromosomes. So I had to split it out and make a bunch of different sweeps. And that's how I got this final look here. Thank you all for watching today. Again, I'm Veronica Falconieri Hayes, and if you're interested in following my work, you can find me on Twitter at FalconieriV, on Instagram at Falconieri Visuals. You can also follow me and my work on LinkedIn, and you can also check out my website at falconierivisuals.com.